the questions in section 6.6, solving quadratic equations by factoring. Well, some of the examples. Just before we start, let me show you something from the book, and it's a review. I'll put it in the notes. So quadratic equations, they're parabolas like this, and there's cases like the first case when talking about solutions, x-intercepts. Sometimes the graph doesn't touch the x-axis. So if you notice, this one doesn't touch the x-axis, so that will have no solutions. Sometimes it touches the x-axis once, like right there. So that type of quadratic equation has one solution. And sometimes they touch twice, and the parabola is opening up. It touched twice, so two solutions. And then this one, the parabola is opening down, but it also touches twice, so that one would have two solutions. The general form to find these solutions, this is it. You equal the polynomial. In this case, it's a quadratic. And you equal it to 0 and solve it. That's what I'm going to show you right now. And there's a video on that puzzle that you guys will have to do. And this is just when you graph it. This is not the standard form. I'll show you in class the standard form. So now I'm gonna do 4 of the examples, and then the other 4 you would have to watch the puzzle video. So this one, based on their properties equal to 0, they want you to solve for x. So it says solve for this. So the first thing you need to know is that each of these factors, so this is a factor and this is another one. Each of these factors you would have to equal it to 0. 0, and then this one will equal also to 0. So this one is already solved for you, so you know one of the solutions would be x equals 0, right? X by itself equals 0, and that would be the solution. So what does it mean? It touches the x-axis at 0. This one, you need to solve for x. So again, I separated these two factors. This one is already done because there's nothing that we need to solve for. It's just x equals 0. And that one has more things, has 2 terms, and we need to solve for x. So plus 2, remember the inverse. So this goes away, so you have 5x equals 2. And then to eliminate the 5 on this side to make it 1. So 1 we divide by 5. So x will equal 2/5. And this would be the solution, the second solution for that. So this is how you do this one. Again, it's intercept. It's where they touch the x-axis, the parabola. Let me do the other one. And you can write, let me write it here, the solutions, before I move on, are 0 and 5/2. Okay, so I'm gonna do example 6. This section has a bunch of examples, but I didn't think of it to be too smart to give you all of them. It's just too much. So you gotta be smart and just hit the key points on this assignment. So 6. So 6, sometimes you might get something like this, and they want you to solve, and there's a number on this side, so we don't have the 0. So remember, these equations, you need to equal them to 0. So just remember, like for example, this one's, I'm not doing example 1, but it's equal to 0. To find solutions, everything needs to equal 0. Again, equals 0. The one that I did was equal to 0. So if you see like this one, that one's equal to 0, so that one's good. For example, that one, I'm not gonna do it, but that's An example just showing you that one's not equal to 0, so you would have to bring this number up to this side. You have to do plus 49 on this side to make this side 0. So I'm just gonna write that. I'm gonna solve it. Plus 49. So now it has the right setup. Now you can start solving. That one is already set up. Equals 0. So again, number 6 not. So that means we need to bring this 4 to this side. So minus 4. So you're gonna have x 2x minus 7 minus 4 equals 0. So this is not like number 3. Remember number 3 didn't have a number here. It was just 0. So number 3 you could separate them from the start because they were already factored. This one has a 4, so this number changes things. So we can't just separate them like that. That's a minus. You can't do that. It needs to be a factor. It needs to be multiplication where two things are multiplying like the other one. So for this one, you will need to distribute this. 2x squared minus 7x, and then you have minus 4 on this side equal to 0. Okay. So now you have it set up. So the next step you need to look is to see if it has a GCF. Can you take away something from here? Do they have the x in common? No. So we can't GCF x. Can we GCF a number? Well, no, because 2 cannot divide 7. It can divide 2, 4, but not 7. So there's no GCF for this one. So you're going to have to factor from here. Okay. So let's factor this. So remember, this is where we're going to do the A and the C because A is not greater than, the A is greater than 1, so you have to do the AC method. A times C would be 2 times negative 4. So 2 times negative 4 would give you negative 8. So you have negative 8, so you need to find two numbers and multiply to negative 8 and add to negative 7. So let's do that. So you're going to have to put negative 8 here. And then let's find the factor. So let's start with, and we need to get a negative, so the bigger number has to be the negative. So I'm going to start with 1 times negative 8. So 1 times negative 8 gives you 8. When you add them, it gives you negative 7. So that's the numbers that we're going to use. So 1 and negative 8, 1 and negative 8. Okay. Those numbers, remember from previous sections, so you would bring this one down. This term in the middle, you would use these two factors that we found. So you would have plus x or 1x, and then minus 8x, and then you bring this one down. Minus 4 equals 0. Okay, so 1 minus 8 gives you that negative 7, because that's positive, that's negative 8, so it gives you that negative 7. So we just change how this one looks into two things. So here, remember, I told you to cut it in half, and here you would have to find the GCF of both sides. So this side, you have an x, both have an x in common, you can take away 1x, and you can't take away the number. You can, a GCF number, I mean, because that one's just a 1. So this one would just be 2x, and that one would be plus 1. Alright. On this side, so that's negative, so we're going to have to, this GCF would have to be a negative. let me do the GCF first. So this one doesn't have an x, but they do have a GCF in numbers, which is 4. 4 divides 4 and 8. So you would put 4, so 4 here, it has to be negative. So that would be the GCF, so that's where you put the negative 4 here. That's why I had the negative initially, but I just wanted to see first where I got it from. So negative 4 would be the GCF. So what goes inside? So 8 negative divided by 4 negative would be 2 positive. And then the x, negative over a negative 4 over 4 would just be 1. So you see, and you have to GCF a negative because we want these things to look alike, and they are alike. They're the same. I mean, 2x plus 1 and 2x plus 1. So it checks. So that means these two terms, they have these in common. You can put them in groups. So you can do 2x plus 1 because they're the same. And then you can put this one in parentheses, x minus 4. And that would be the factor of this. So remember the steps. And that's equal to 0. Now, this is the easy stuff. We already have the factors. So you have to, it's equal to 0 to find the solutions, the x-intercepts. So this is where you find the solutions. So just go ahead and start solving for x here. So x would equal 1/2 on this side. And on this side, all you have to do is add 4 to get rid of the 4. So x equals 4. So the solutions are those two. Are negative 1/2 and 4. That's how you do that. Okay, example, I'm gonna do example 9 really quick. So example 9. So this is the original question. So solve and they give you this long thing. Sorry. They give you this long thing. And that one's already factored out. That one, the 5x minus 1. It's equal to 0, so we don't have to worry about bringing things to this side. But then this is not factored. So what I did here for 6, this easy method, you would have to do it for this stuff. So I'm just going to put a note here. So you would have to factor using the A times C grouping method. Well, I just did on the previous one. So this would be done for this quadratic expression here, or the polynomial, this polynomial here, however you want to call it. Okay, so when I did this, I got these 2 factors here. So for this question, you're gonna have 3 factors. So once you have that, all you have to do is you can equal h to 0. So this one would be plus 1, 5x, 1 minus divided by 5. So x equals 1/5 for this one. And then this one, minus 3, 2x minus 3 divided by 2. So x equals negative 3/2. And this is just minus 6. So x equals negative 6. So this question has three solutions, and you're gonna ask how come it has three solutions? Because quadratic equations, the highest they can have is 2, and that's because this is not a quadratic equation. So this is a quadratic equation in itself, this one. But you have these other part here. Where, let's say we were to distribute this into this. But when I distribute that, let's say we were gonna create the polynomial, the original, right? And we're going backwards. So you would have to distribute these terms into this one. X times x will give you x cubed. So this is a cube function. Like you would have, and cube functions can touch the x-axis 3 times. That's why it has 3 solutions. They kind of look like this. Just let me draw it here. Imagine this is the x and the y. So they can look like this. So they touch 1, 2, and then 3. Okay, so these are the solutions. Solutions. It's 1/5, negative 3/2, and negative 6. Okay, so that would be 9. Sorry, I didn't have time to do that. You guys should know how to do that. And then 11. 11 is really easy. So 11, the only thing that changes is they're gonna ask you differently, like find the x-intercepts of the graph. Okay. So we don't have a graph, but you don't need the graph. So all you need to do is when you have this question, so remember it's like finding the solutions. The x-intercepts, it's also the solutions. These two things are the same. And there's other names for it, like there's I forgot the names, but solutions, x-intercepts, and the zeros, they call them zeros, also find zeros. And there's another one, like 2 more that I'm missing. But all you have to do is here equal these quadratic equation to 0. So make y, so let y equal 0. So that y will become 0. And then put this on the other side. And you could have put it on the other way. Like most of these questions have it like this. So, but that's what it means. When it says you're gonna do this, and then you're gonna factor, right? Because we want to find the solutions. To find the solutions, you need to factor. Okay, so how do we factor this? Well, this is just a normal factoring. You find 2 factors that you multiply to 4 and add to -5. So if you want to do the table, that's fine. 1 times 4, and that's negative. So you know that both will have to be negative. Right? Because 1 times 4, you believe it's positive, you will get this one, but you will never get this one because that's negative. So 1 times 4 gives you negative, negative will give you that positive. When you add, then it will give you a -5. -1 plus -4 will give you -5. So those are the factors. So in this type, the A is 1, I mean. So we don't have to do the AC method. You don't have to do AC method for this type. Just set it up like this and then put -1 and -4. And then separate them like that. Set. And then solve for the x. So x equals 1. And x equals 4. So those two are the solutions. Now, for x-intercepts, remember we write them like this. So x-intercepts, so this one would be 1, and the y is always 0. And for that one, it would be 4, and the y is always 0. So if we look at the graph here quickly before we finish, right? So let's 1, 2, 3, 4, 1, 2, 3, 4, 4, 1, 2, 3, 4. So this x-intercept would be at 1, 0 here, and that one would be at 4, 0. 1, 2, 3, 4. And we know it's a positive parabola, so 1, 2, 3, 4. Just gonna touch around here. I don't know what the vertex is because we didn't find it, but that's how more or less it would look. That's it, guys. Thank you.